ECE 496 Senior Design by SR08. I'm Chris Harvey and I'm a computer engineering major.
Matt Tingen, computer engineering.
Jonathan Flowers, electrical engineering.
And Oliver Carter, electrical engineering. Our robot is mostly comprised of PVC. In order to overcome the insulating properties of PVC, we had to create heat sinks for our motors. These heat sinks allowed us to avoid thermal issues. We are very careful to stay within the specified height and width constraints, and due to the PVC construction and precise measurements that we used, our robot maintains a very rigid structure. It's well organized and well balanced.
When evaluating the electronic requirements of our project, we decided to focus solely on the TIVA launch pad since it was originally required for the final presentation. Also, in order to calculate a stable angle measurement, we required an accelerometer and gyroscope. The MPU 6050 was purchased due to its dual functionality. LS7366R chips were used to interface with our Clemson robotics motors. A dual-channel H-bridge was used to drive the motors. Lastly, XB wireless RF modules were used for communication due to their long range and stability.
Hardware overview. We use thermal tape for heat dissipation, acrylic to house the electronics, PVC pipe to form the structure of the device, foam padding for safety, Clemson robotics wheels because of their compatibility with the motor, and solder, wires, and other equipment for miscellaneous purposes.
Since our robot only rotates around one axis, we pass the relevant axes to a complementary filter to get an angle measurement. This resulted in an accurate and stable angle which represents how far from vertical the robot currently is. This angle is important for feedback for the motors.
In order to establish communication, we chose wireless XB Pro modules due to their reliability and long distance range. They're in a simple sender and receiver configuration, and the transfer of a character byte represents a command for the TIVA.
To control the output of the motors, we used an H-bridge pre-built board. The board utilizes the L289N dual motor driver chip. This system can provide 12 volts and up to 1 amp for each motor. Seen below is a truth table that shows how the input pins can be used to control the behavior of the motors.
Since our motors were encased in PVC, we needed a way to keep them from overheating. To do this, we made our own heat sinks. We wrapped the motors in thermal tape inside the PVC and used double-headed metal studs going through the PVC to draw heat out. To increase the conductive surface area, we wrapped the outside in aluminum ventilation tape.